by, we need to understand what is the meaning of exactly divisible. Okay, when we say that something is exactly divisible, that means the remainder is 0. Okay, and that also means that it is a factor. Okay, so if I were to rewrite this sentence, okay, using these words with numbers, right? Okay, I can say, for example, 8 is exactly divisible by 2. Okay, so that means 8 can be divided by 2, and 2 is a factor of 8. Okay, so with that in mind, okay, since x squared plus x minus 2 is actually a quadratic factor, right? But we know that we cannot have a certain value of x to be placed inside here, okay, very easily to be determined from this. Because we want to take a value of x and then put inside to see whether the remainder is 0 or not. Okay, and since it is a factor, the remainder will be 0. Okay, so from x squared plus x minus 2 itself, okay, we need to realize that it can be factorized. Where I get x plus 2 and x minus 1. Okay, so the choice of x value that I can have will either be negative 2 because this part is 0, or else 1. Okay. So this part is equals to 0 only under these two options. So let's name the polynomial that we have by fx. Okay. So when x is equals to negative 2 and I put it inside the polynomial itself, we will be getting this. Okay, and this has to be equals to 0. Reason being that if the polynomial can be divided by this one, it can surely be divided by this as well. So for example, maybe instead of talking about 8, okay, I can say that 16 is exactly divisible by 8. Okay, and 8 is actually 2 times 4. I will also realize that 16 will be divisible by 2. 16 is also divisible by 4. So therefore, when I have this polynomial over here and I divide by this quadratic expression, okay, and if this quadratic expression can be broken up into two factors, it will surely be divisible by this one and also divisible by this one. So that's why putting in negative 2 will suggest that the polynomial is divisible by x plus 2. Okay, where x plus 2 is a factor. So I can put in the remainder to be 0 over here. Unknown, so we need two equations to solve it simultaneously. And to get the other equation, we let x to be equals to 1. And the remainder will have to be 0 as well. Yes, did I calculate wrongly?
The 8 to 4a.
Oh, sorry. Right. Right. Thank you. Why you erase the center part? Erase this out. We take a look at exercise 4.2, question 18. We are given this function over here, okay, and we want to find the values of p when fx has a factor of x minus 1, x plus 2, and then in part 3 we want it to be such that it is a factor, as in x plus 2 is a factor but not x minus 1 is a factor. Okay, so when we say that x minus 1 is a factor, what is the choice of x value I will use? What's the choice of x value that I should choose? Ling-Hui, what do you think? If I say that x minus 1 is a factor, what is the x value that I want to put into the function? One. Okay, so we choose x to be equals to 1. Minus 1 is a factor, okay, this value for 2p squared plus 3p plus 1 must be equals to what? Haley, what do you think? 0. Okay, good. So it has to be equals to 0 because it is a factor. Okay, then after that we will have to factorize this one. And we find that p is either negative 1, otherwise negative half. Okay, I want you to spend the next 3 minutes to complete part 2 and part 3. Okay, part 2 is something similar. Alright. Please take 3 minutes to answer what question 3, part 3 means. Okay, let's look at part 3 then. Alright, I hope that part 2 you are able to get the answer. What is the answer supposed to be? What's the value for p, Anson? 1 or 2? Okay, sure. You all get 1 or 2 also? Negative 1 or negative 2, right? Okay, let me maybe just write that down. Or negative 1. So looking at part 3, right? Okay, question is asking for a value of p whereby x plus 2 is going to be a factor, x minus 1 is not going to be a factor. for x minus 1 to be a factor, we need p to either be these two values. Okay, and then after in part 2, p having these values will allow us to have x plus 2 to become a factor of the polynomial. Okay, so if I were to choose p equals to negative 1, okay, then both x minus 1 and x plus 2 will be factors. If I were to choose p is negative 1. Okay, if I were to choose p equals to negative half, okay, then x plus minus 1 is a factor, but x plus 2 is not a factor. So now, if I were to look at part 3 again, I want x plus 2 be a factor, but this one not a factor. So therefore, the value for p will have to be p equals to negative 2 to allow that. Understand what I'm trying to say? Anybody didn't catch what I said? Yeah? Now let's go to something slightly more abstract, with lesser numbers, more algebra. Let's look at question 20. Polynomial using fx is that having the x over there, it keeps us reminded that the variable, okay, the variable is going to be x. That means those are the things that keeps on changing. That is what you can substitute things into. The other unknowns that we see over here, the k and the a, right, they are all just constant. That means it is a fixed value. Okay, it can never change. Right? So that's why we can go and solve it. Okay? So in this question itself, fx gives a remainder of negative 32a cubed when divided by x plus 2a. And we want to find out what is the value of k. So because we want to divide it by x plus 2a, the choice of our x value will have to be negative 2a. So therefore, we let x equals to negative 2a and we substitute this into the entire function itself. And we only focus on changing all the x to negative 2a. Okay, so the function, the naming of it makes things very clear for us on what to substitute. And we simplify over here, so this will give us negative 8. Or you want to factorize out the negative 2 is also fine. But the reason why I do this is because the remainder is negative 32a cubed. Okay, so therefore, I will get this here. Okay, then I can cancel away the a cube, right? The reason why we can cancel away a a non-zero constant. Okay, if you recall, I have mentioned before, if we are given an unknown, we don't divide by unknowns. We cannot divide by unknowns. Right? The reason why we cannot divide by unknowns, Joseph, can you please wake up? Okay. The reason why we don't divide by unknowns is because there is a tendency for it to be zero. When it is zero, I cannot divide by zero. Okay, but the question has really confirmed for us that it is non-zero. Okay, so therefore it is safe for us to divide away a cube. Okay. Otherwise, usually we don't actually divide by unknown. Okay, so therefore we have negative 32 equals to negative 40 minus 2k. Then it will be a very simple solving procedure. Find that k is negative 4. Right? The value of k, which is negative 4, to determine whether x squared minus ax minus 2a squared is a factor. Okay, whenever we are given something that is quadratic and we want to check whether is it a factor or not, okay, we need to break it up into two different factors first, into linear factors. That means we need to factorize out x squared minus ax minus 2a squared. Because our remainder theorem and factor theorem doesn't allow us to check or verify, okay, for remainders of factors that are quadratic. It must be linear. Okay, meaning it must be like 2x plus 1, 3x minus 1, negative x plus 1 type. Okay, only a single x, x to the power 1. Okay, so in this case, I must actually factorize this, right? There seems to be a lot of unknowns, there's a lot of a's going around. Okay, if you remember your course method, okay, you can actually do factorization with more than one unknowns, more than one variable. Okay, so our factorization will be x plus a and x minus 2a. Alright? So in order to check whether something quadratic is a factor or not, okay, we must see whether the two separate linear factors are they going to be factors. Okay? So if the remainder is 0 for both of it, then we will know this one will have to be a factor of this polynomial. Okay? So the fx that we're looking at is now this, after I change the k to be negative 4. So with x plus a equals to 0, I will choose x to be negative a. And simplifying that expression, we get 0. Then we can conclude x plus a is a factor of fx. Then now we check the other one. Minus 2a and x plus a, they are both factors which we verify using the factor theorem. Okay, we will then be able to prove that the multiplication of it, when expanded gets us this, okay, is going to be a factor of fx. Okay. Hopefully familiar with remainder and factor theorem. Okay, go and practice it. Alright. We'll move into 4.3 cubic polynomials and equations. So please go and do the homework for 4.2, which I've given to you as a set already. Differences of cubes. Okay, we have learned about sum and differences of squares. Okay, or in particular differences of square, where I know that a square minus b square will give us a minus b, a plus b. Okay, but then, alright, what about a cube minus b cube and a cube plus b cube? That is what we're going to be looking at. Okay, in this section, or part of this section. Okay, the same doesn't apply. Okay, there is a unique way of factorizing it. Okay, in your textbook, they have given a very simple acronym, okay, called SOAP. Okay, which I thought was very useful. I didn't really know of this until I see this new textbook. Okay, I always struggle with memorizing this also. Okay, so what this says is that S represents the same, O opposite, and AP is always positive. So how does this apply? Okay, the A cube plus B cube, okay, will give us two factors. One will be linear, another one quadratic. The linear one will be having A and B, okay, so both are the same. Then after that, we will have A square, AB, B square, AB, B square. Okay, so you need to at least remember this format. Right? Then after that, apply the slope. Okay, same means that this operation here will be the same as this one. So this is a plus. O means opposite. Okay, AP always positive. Okay, so it matches accordingly. Right? Likewise, this one, same, negative, O positive, always positive, plus. Okay, I'll explain to you why this happens. Okay, let's do something else. Oh, sorry. Thank you. Okay, let's consider something like that. If I want to factorize x cubed plus 8, using the formula itself, we will know that it's going to get us. We need to know that 8 is actually 2 cubed. So using this formula, I will be able to see that it's x plus 2, x squared, minus away a times 2 plus 2 squared. Okay, you're expected to memorize that formula and expected to factorize in this manner. What I'm going to show you next is the explanation of why this happens. Are you ready for the proof? If I let fx to be x cubed plus 8, okay, I want to verify. Okay, I want to show that x plus 2 is a factor. Okay, because over here, this tells me that x plus 2 is a factor, right? Because x plus 2 times something else. So this is a factor, this is also a factor. But my factor theorem only allows me to prove it with something linear. I can't prove it with this one. By the way, this cannot be further factorized also. You can go and try many times. Oh wait, yeah. Oh sorry, this one is x. Okay, you can go and factorize many times. It can never be factorized. Okay. So I want to show that x plus 2 is a factor of this fx. If I use my factor theorem, okay, I will choose that x is negative 2. Okay, and that will mean that I will have negative 2 cubed plus 8. This is negative 8 plus 8. And therefore 0. So factor theorem tells us that x plus 2 is a factor. Then how am I supposed to get the quadratic one if that one cannot be further factorized? Okay, I can do long division, right? Because I know that if I take x cubed plus 8 divided by this, I will get this one. Just like how if I have 16 equals to 2 times 8, 16 divided by 2 should be equals to 8. Correct? So if I were to do that, long division process, remainder will be expected to be 0 because factor theorem already tells you remainder is 0, right? Okay, and the quotient is x squared minus 2x plus 4, which is this part here. Okay, so going through this long process helps me to show you, okay, that the factorization over here is correct. Okay, and x squared minus 2x plus 4 can never actually be further factorized. Likewise, in the general case like this, okay, the quadratic portion can never be further factorized, okay, when we deal with cubes, sum and differences of cube. Okay, so in the past, without this SOAP thing, whenever I don't remember, I actually have to do factor theorem to do a long way to help me remember. Okay, so I hope that this acronym itself will help yourself to remember all this plus, minus, plus thing. Okay? Without having to go through this long process. Okay? But the second section of this 4.3, we have to go through this long process. Right? We will talk about it later. Okay, any questions? Alright, let's just look at try 14 now. Okay, I want to factorize 8x cubed plus 1. Be able to notice what are the things that are being cubed. Okay, so this power 3 is only belonging to x. I must ensure that it is the entire thing that is being taken cubed with. Okay, sorry. Okay, before I can actually do my formula. Right, so because it is a plus, okay. The formula, I will have this. Then I need to simplify it. And this will be the factorized form. Okay? Okay, give you about 2 minutes, right, to do part E. Exercise 4.3, question 16. Sorry, question 6 now. Cube, right? Then how? How to do? Joseph, you seem very well stretched. Can you tell me how part A? How to factorize part A? If this is the formula we have learned. That one, power 4.
You factorize out the x.
Factorize out the x. Can you factorize something else also?
The 2 and 2x.
Yes, okay, very good. So we factorize out the 2x. So that whatever that remains will actually be Okay, 27, we need to recognize that it is a perfect cube number, 3 cubed. As well. Try to actually factorize this using the formula. So this time you need to extend. Alright? Then after simplify, you will get 3x squared plus y squared. Does anyone not understand? You need to recognize that x plus y over here is the a that we're looking at in the formula, and this is the b that we're looking at. So a minus b, a squared plus ab plus b squared. Sorry? Where? This one? No, what? X squared, x squared, x squared. That's 3.
2y squared, 2y squared.
2y squared, y squared minus y squared plus y squared.
Oh,
So you only have 1y squared. Okay?